like, oh crap, well, we didn't think about dropping perms on that because that doesn't really make sense. Oops. So I kind of thought that was funny as a side note because it had asterisks next to it in his paper. He's like, oh, by the way, somebody failed. Fail. Another thing that it does, so the heap actually grows towards the stack and it's, all contiguous and all that stuff. When you change this, the heap grows towards null. So when that occurs, you're going to anger a lot of other things by doing that. So by doing this, you're going to find heap corruption a little bit easier, in my opinion, than doing it the general routine way. And once again, when you make things easy, then hey, all right. A few more additional tips. So let's talk about PowerPC for a second. Anybody heard of anything called instruction caching? I see 2 hands. Sweet. 3, 4. Sweet. So PowerPC and I guess the other RISC guys came up with this brilliant idea. Why don't we cache instructions to make it look like we're running faster? While x86 doesn't have to do this because they feel like they're natively running faster, which that's a whole other debate, right? And they feel like instruction caching will help speed things up. So when if it knows the next 4 bytes to execute without actually having to go through and read it every time, then it's going to read 4 instructions at a time. Which 4 by 4 is, I'm from Texas, I don't know math. So 4 by 4 is whatever. 16, just kidding. See, I can do it. It's going to continue to keep these 4 instructions in the cache, so it doesn't have to keep checking every time. It's going to check every 4th instruction. One of the negative parts of this is if you don't do something what's called immediate, so there's stores and loads and all that stuff, which we can compare it to x86 to help better visualize it for some people that aren't familiar with RISC and PowerPC and all that. If you add an I on the end of most of those, it makes it immediate. And if you don't do it immediately, everything may look good on paper, but the true reality of that is you're going to be knocking your head up against the wall because you're like, oh, well, this should work. Excuse me. And it actually doesn't because it didn't actually change it in the cache. It only changed it at that location. So it hasn't reread it. So you've got to actually force it to recheck that and move that immediately. There are 2 different types of caching. Instruction caching, which is going to affect your shellcode. If you're not storing things immediately in, say, registers and other locations in memory, if you're not doing it immediately, then once again, you have to wait a few more instructions for that actually to take effect. And what happens is you expect a value to be there, and oh, by the way, it's not there. Yeah, it actually checked out. It's like, no, I'll be there in a bit, but not exactly there yet. And the other one is data caching. And so data caching is not that big a deal, but same stuff basically. People way smarter than me came up with all this stuff, say, oh, well, how can we make it run even faster? And so this has kind of been around for a pretty long time. And it seems like it still holds true today that what they're doing seems to work out well for them. All right. So I actually took this blurbage from one of IBM's PowerPC pieces of documentation. So, so it's up to 2 instructions every cycle. So every 2 instructions, it's going to go back and get another. And what it does is it actually goes out, fetches it, as you can see in the documentation here, and then it'll decode it or basically interpret it and make sure, oh, this is what I'm supposed to do. And by doing that, it's actually reducing the reads in half. So you like that math? Oh, great. All right. So 4 instructions are read from the cache, and then they're placed in a temporary buffer, which is actually it's a tiny little buffer that's actually in the processor itself. And then this caching is arrays to be allowed access as little once every 4 instructions. That's what I'm trying to say. And it's significantly reducing power consumption as well. And because we're all going towards a green environment and all that stuff, and electricity costs a lot, or it seems to be costing more and more. IBM and others thought it'd be, oh, well, here's at least one more way we can kind of reduce the voltage just a little bit more in the amps and not draw as much power. because when you compare power and some of the other risk to x86 and x86-64, you'll find that it will draw more power if, well, I mean, it's still drawing more power, let's be quite honest, but it would be even more. So they're like, well, we're doing you a favor, but not really. They didn't do enough favors. So like I said, the instruction caching is what's affected. If we're caching instructions, then our shell code is going to pretty much flop because, once again, we expected something to be here. So if we're calling a function and we need certain register to have certain values, when we do the branch and they don't exist, then it's not going to run as expected, or it's going to be a previous value that you don't really control, and it's not going to work out for anyone. So with doing immediate on all your different types of assembly, then you're going to get what you actually see instead of expecting what you are supposed to see, and that doesn't actually occur. So it looks like I'm running a little fast. I was kind of excited and can't wait to get here. So I can do a dance for you. Let me do a little review. So once again, two types of methodologies here. One, I feel that I kind of had something to do with, enlightening and showing. I may or may not be the first person. I don't know, but I felt like it was important enough that if we documented and actually got it out there, then other people will know how to both utilize this in penetration and testing environments, as well as maybe it'll get IBM moving forward to catching up with some of the other operating systems. So I mentioned Solaris and the BSDs and Linux and Windows. They're all doing all these different types of things to thwart this type of attack that's been around since the 90s, early 2000s, and we are now in a new decade, and AIX is still relying on the same old algorithms. It could be that they feel like it's hardened and trusted and they know it works and they're done with it and they're working on other projects. It could be that they feel like if by doing these sorts of things, maybe execution takes longer and maybe they're concerned about that. I don't know. Or maybe they just want it to be the old dinosaur and they're not looking forward in the future. But I do have some confidence that at some point in time, IBM is going to look back at this and go, yeah, we need to fix this just a little. So it's probably going to be like 6 lines of code to actually change, and I can't really envision that being too much of a pain. But I made that up, right? But as a developer, I kind of imagine the 6 lines that I would use, and then wham bam, there it is. So by the time I get off this podium, they may have already fixed this. I don't know. So once again, my name is Tim Shelton. I'm the Senior Vice President in Research and Development for a company called Hawk Network Defense. Once again, we're a SIM provider, and if you're interested in that, we can talk later. But so we do fun stuff, and I also like to play with iSeries. And because we work with an IBM Premier partner, that's what allowed me to have access to these types of machines, where I probably in my day job, if the rest of it, probably wouldn't have access to, because we deal with just a lot of x86 and maybe a little Mac. And so, all right, I guess we're going to go to questions because I saw a hand come up. Hopefully it's not a troll question. Go ahead. Oh.
So what's the most accessible if somebody wanted to get a hold of somebody who run modern AIX, like modern AIX?
Yeah, can you get the mic to him because I can hardly hear you? Sorry.
Sorry, the question was, what would be the most accessible AIX box that you could get a hold of off of, like, say, an eBay or a Surplus that would run the modern version of AIX?
I kind of think the answer is no. No,
it's not. That's not the answer.
I know. It's not the right answer, but it's the one I'm thinking of. So I was actually recently given an RS6000 machine, and these older machines will only run up to 5.1. In some other instances, if they're really old, they won't even run that. So it seems like Power 6 and Power 7 is what everybody's headed towards, and with that, you got to buy a newer machine. You might find one pretty cheap. I can't tell you the exact model that you'd probably be looking for, but it seems that IBM's pretty proud of what they have, and they ought to be, because they're the leaders of computers in a lot of senses, so it seems. So, but
I know like the old 6000s you could get the 5 and 4 boxes. They had like some like desktop type equivalent ones that still ran the same. That's actually probably part of the reason why there's not as much.
You think so?
Code floating around. You got to get a hold of the boxes, right?
Yeah. So and that's like 90% of it. So if you're a security researcher, it doesn't take much to find something AIX. So it seems. But I think you're right. I think it's a niche that. So I talked about. Oh, by the way, all these different people are running AIX. Governments and medical field, and a lot of commercial companies. So commercial enterprise are running these types of systems, but none of the security researchers have really got their hands on it. So I had a reference earlier to how Linux in the 90s was called secure because nobody looked at it. It's kind of the same thing. It seems like IBM is calling it secure, and maybe they mean secure like permission secure. I don't really know. But from an exploit development perspective, it's an absolute dinosaur. It has absolutely nothing. There's no randomization. I found that no DEP, when I was doing this, while I was storing stuff in the environment variable, which is actually on the stack, it had no problem running my shellcode. No problem at all. So we're heading towards that direction, and so we've got to figure that out at some point. So with a 4-byte overwrite, it's going to be a whole heck of a lot harder to do return-oriented programming or return-oriented exploitation, and like return to function, return to libc, things like that, than it naturally would be, because you've only got one overwrite. So you got to pick a good one. So two things independently would actually thwart this: ASLR and DEP. But then together, we're in the same environment that we always have been, where you're begging for some data leakage, so you can find a memory address somewhere that you can preload and go, oh yeah, okay, that's what I'm using. So I found in my research that's semi-rare. I mean, not really rare, but rare in the sense that when I need leakage, it's never there, or never when I'm looking for it. So, and I say never. I've never been. I mean, rarely, just rarely. So, all right. Any questions? I actually have about 5 or 6 minutes left. So, sweet. We all want to hear you.
You mentioned DB2 and Oracle and a bunch of others. How often are you seeing WAS on AIX?
WAS?
Web Sphere Application Server.
Oh, yeah. Often. I mean, very often. So Lotus and all the other stuff. I mean, so IBM technology runs in an IBM environment on IBM hardware because IBM has all the ownership to it, and they can make more of a profit on it. But also, it's tested, it's tried. When people invest in these types of environments, they're going to go, oh, well, we may as well just use IBM's web servers, IBM's this, IBM's that, because why not? We're an IBM shop, which I know it seems like that's getting a little bit rarer and rarer than it used to be because of some of the hardware becoming so cheap. It's a complete commodity nowadays. But I'd say that any of those types of applications, that's actually a good one. So if you can think of any others, I'd be happy to hear. But the major ones that I see that are pretty impacting, it typically ends up being PeopleSoft and JD Edwards and databases and databases like Oracle and DB2, and with those types of applications, that's typically where your mission critical data and mission critical stuff is going on and is being relied upon by the business side of the company, not the IT side. And so maybe WebSphere may not be as important if you're just serving up data that's public and it's just a nuisance that the stuff's down. But we talk about, you see some of these compliance issues like PCI and SOX and GOBA and HIPAA and all that, right? They're focused on, okay, where's the important data? First of it, is it important? Because you have to identify that. Where is it stored at? And then do we have the right access controls around that to ensure that it's not being snatched out by people that we don't want it to? For example, maybe I shouldn't plug that. There's a university local from where I'm from that just had a major outage, like 27